Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and I'm finally getting around to making some videos for my UF. Just did one on sketching functions, the work for this week, but this is from a couple of weeks ago on inverse functions, and specifically some strange words like domain and range. These are particularly tricky and aren't usually used in these kinds of questions. But actually, once you understand what they mean, answering questions like this becomes very, very straightforward. Let's take a look. First of all, question 14. Find the domain, range, and x and y intercepts for the function g of x equals 5 minus 1/3 of x. Okay, so x and y intercepts implies that we're going to have to sketch this. I think it's a good idea to do so. So let's get cracking with it. Of course, before we do get on with sketching, let's double back and just define what we mean by domain and range. Now, let's be as clear as we can here. The word domain relates to the inputs of a function, okay? And the word range in this particular topic regards the outputs. So I might have a set of domain numbers of inputs that would lead to a set of corresponding range output numbers. Now, this question is pretty generic. Find the domain and range for the function g of x equals 5 minus 1/3 of x. So when we're asked for just the generic domain and the generic range, we need to look at this function and think to ourselves, okay, are there any limits to the inputs that I can put into this function? Now, you might have a question of something like, oh, I don't know, f of x equals 9 minus, let's say, for instance, 9 over x minus 5, right? 9 over x minus 5 might be our function. There's a limitation to what we can put into this function. If we put x equals 5 into this function, it becomes 9 over 5 minus 5, which is 9 divided by, 0, which doesn't work. So x equaling 5 cannot be part of the domain. We'd say the domain is the set such that x is any real number, that sign R means real numbers. But x cannot be equal to 5 because it would result in this division by 0, which doesn't work. Okay, so there may be limitations on the domain. All right, now if we look at this function up here, 5 minus 1/3 of x. Well, if we think about this for more than a few moments, we realize that the x inputs, they can be anything. They could be positive, they could be negative, they could be any decimal, any fraction, even 0, and there would still be a respective output for this. Okay, so for this particular function, we say that the domain is true for x being any real number. Okay, that's the sign for real numbers, and that just means decimal placey numbers. Okay, and if that's true, if any decimal placey number can be our inputs, then our range outputs can be well, any real number. The function can take the value of any real number too. Now, if you notice for questions 14 and 15 and 16 and 17, for all of these domain range questions, they all relate to pretty straightforward linear functions, straight line functions. Even this one, question 17, where it's just generic and algebraic, the domain and range will still hold true to this general rule. Whenever you have a straight line function like this, just a linear function, the domain and range are just going to be the set of real numbers. Okay? That's the most important element of I think, why people are confused by the language of this question. All right, and just be aware, obviously, there will be some functions for which there will be limitations on what the domain can contain based on what you see in front of you. Generally, if it's a division by anything to do with x, then there'll be a value of x that means that that division will be 0, which doesn't work. Okay? Now, for the rest of this question, find the x and y intercepts for this function. Let's take a look at this first one, 5 minus 1/3 of x. Let's treat it as if it was a graph. Y equals 5 minus 1/3 of x. Let's grab a ruler and do this sketch. There's my y-axis, and there's my x-axis. There's 0. Let me just make it visual for you here. The y-intercept for any straight line graph is the numerical element, so 5 is a sensible and the indeed y-intercept for this. Minus 1/3 of x means it's going to be pretty flat. All right, and it will be sloping downwards because that's a negative gradient. Now the question is, if x equals 0, y is going to be 5. If y equals 0, what does x have to be to make this true? Okay, in other words, 0 equals 5 minus 1/3 of x. What does x have to be? Well, that means 1/3 of x equals 5, so times both sides by 3. X is going to be 15. So the x-intercept is 15. All right, so we found here the x and y intercepts. The x-intercept, 15, 0, and the y-intercept, 0, 5. All right, and we've also produced a neat little sketch of this graph. And you should see a connection between what this graph looks like. In other words, this line continues into infinity in this direction. The end of this line continues into infinity in this direction. There are no limitations to what the x and y inputs are going to be. They're going to stretch infinitely in both positive and negative directions for both the x input and the y output. That's why we label the domain and range x equals any real number, any decimal placey number, and the same for the output range as well. Okay, that's effectively quickly producing a little sketch of this function and finding the x and y output. Now, the next part of this, part B, just to briefly finish, is to find the same for g minus 1 of x. Okay, now we already know how to find the domain and range. That is true for all of the parts of all of these questions. The domain is going to be all real numbers, the range is going to be all real numbers. But in order to find the x, y inputs, we need to first of all take the initial function, rearrange it to find the inverse, and then sketch. So let's work this out first. Y minus 5 equals negative 1/3 x times both sides by 3. 3y minus 15 equals minus x. We need to make both sides switch the polarity around, make x into positive, which we'll do by making 15 from negative 15 into positive 15, and positive 3y into negative 3y. Okay, so having swapped that around, let's swap the letters around and actually formally, or sorry, that should say g. G minus 1 of x is going to be 15 minus 3x. That's the method that we've been going through in recent lessons, and that's the inverse function. Now, in terms of that sketch, we can sketch that too. Where the y-intercept is 15, and then minus 3 is the gradient, so it's going to be a lot steeper, down like that. Okay? And you might see what I'm trying to get at here. The x-intercept, if you do the same method as we did before, is going to be 5. So the x-intercept is 5, 0. The y-intercept is 0, 15. Which, if you notice, if you pay attention to the other graph over here, is the x and y values of the previous intercepts swapped around. Okay? So the y value of the previous y-intercept becomes the x value of this x-intercept, and vice versa. All right? That is, in essence, question 14. Been going for a few minutes now, so I'm going to finish it there. If you understand how this process works for question 14, then honestly, questions 15, 16 and 17 are going to be more than doable for you. The most important element is think about, are there any values of x here, that can be eliminated from all the possible inputs? In the case of these questions, the answer is no, that there are functions that do exist for which there are inputs that can be effectively eliminated, that make the maths of the function impossible to do. The rest is just sketching and working out the x and y intercepts in conjunction with the inverse function work we've done in recent weeks. I hope that that helps you. Apologies that that was so late in coming. All that remains for me to say is keep working hard. This work is likely to come up in the exam after the summer break, so make sure that you are well acquainted with it. Take care of each other and yourself, and yeah, I'll speak to you very soon.